So thank you all so much for having me today. My name is Ryan Moog, and I have the privilege of leading Cerner's research group. There's actually, so Cerner is a large organization. There's actually about 100 of us that are full-time focused on research. And very excited about the possibilities here and working with you all. This has been a great event today. I was telling someone earlier, that's not always the case. So like one of our longtime clients is the University of Southern California. And they were having a research symposium, and our on-site Cerner person said, you should go speak at the research symposium at USC. And we have a lot of clients out in the LA area, so I went out there, show up for the event, and it's a movie research symposium, which is not actually something that I'm qualified to speak on. So so that's good. So we're 2 for 2 there. And also, really appreciate just the invite in general. A couple of roadmap items before we get too far down the path here. Number one, we're going to cover quite a bit of ground of research, as I just illustrated, can mean a lot of different things to a lot of different people. And so we're going to talk about clinical research informatics or clinical trial support. So we'll definitely cover that. We're also going to cover data science support and where we're headed there. So just a little bit of background there. We're also, so that's kind of number one one delineation, so clinical trial support and data science support. We're also going to talk a little bit about things that exist today. So things that have already been implemented that you all can go use that exist and have been implemented here. I'm going to talk a little bit about, especially in the back half of the presentation, about things which are on the roadmap of, like they exist, they're real things, but things that we haven't quite implemented here just yet, but do plan to. And then there'll also be a couple of items in here that are a little bit more vision, a little bit more where we're headed as an organization as Cerner. So you'll get quite a bit of mix of that. And I'll try and signpost as best I can here, so at the end of it, you're not like, Ryan, why doesn't this exist yet? And it's like, well, we're getting there. But we are going to cover quite a bit things that you can go access here tomorrow. So our agenda, like I said, the first half is going to be clinical trials support. We're going to talk a little bit about clinical research in the EHR, how we got to where we are right now. A little bit about clinical research interoperability. So as you have seen today, there are a host of different systems out there. And in my job, which I always tell people I have one of the coolest jobs at Cerner because I actually get to work with hundreds of our different client organizations who are at all different parts of their life cycle and all different shapes and sizes. And so like one of the clients that I work with is Cox Healthcare in Springfield, Missouri. They run 8 to 10 clinical trials at a time. And so not exactly a research powerhouse, but obviously they take it very seriously and they excel at what they do. All the way up to Stony Brook and MedStar and Georgetown and St. Jude, which is basically a pharmaceutical company themselves. And kind of everything in between in terms of how many clinical trials they're doing, how much data they're accessing, and how much work they're actually doing in the research space. We're also going to talk then about data access and data networking and how we move data from system to system and some different capabilities there about what's coming down the pike. I would imagine that most people in the room are pretty familiar with Cerner, but in the event that you aren't, we are a large electronic medical record vendor and the one used here for a number of years. Over the course of time, we've gotten to be quite large. So now have, this slide's even a little bit out of date, have close to 30,000 associates worldwide that are constantly working on improving the way that we offer healthcare IT. And that used to just mean a lab system, and then it was an electronic medical record, and now it's everything from acute inpatient documentation that you're all familiar with, all the way to patient portals for state-run Medicaid agencies and everything in between. My job is to tie all that together to work with folks like you. So the individuals who are out there on the cutting edge of research, are actually doing clinical trials, are needing data access to go support grant-funded initiatives. So trying to just assimilate all that to work for you. So when I talk about research, and when I think about what is it that, when we define research, what is it that Cerner's focused on? Everything from cohort identification and patient recruitment, so a little bit of what we talked about before, and getting data out to those systems, getting data out to things like I2B2, supporting patient recruitment efforts inside the EHR, clinical trial administration, so actually representing clinical trial data inside the EHR, operational information like when is this patient, when were they enrolled in the trial, have they been consented, when are they going off the trial. Data capture, so we'll talk a little bit about our work with Smart and Fire and the ability to push data out to data capture systems. Research compliance, like I'm sure there's at least one person in the room always who is extremely focused on 21 CFR Part 11. If you are that person, I'm happy to share a whole host of documentation about how the EHR can be 21 CFR Part 11 compliant, how you can reply to sponsor questionnaires. Real world data, so getting data out of the EHR to go do other things with it, put it in other systems. And then finally, research grants and collaboration. So we actually have, when I say Cerner research, part of what we do is also study execution. We actually have research study and site administrators who are doing specific studies. For example, we actually run one of the longest HIV cohorts in America. I think it's actually one that's run here, if anyone's familiar with the HOPS study, the HIV outpatient study that's run by the CDC. When you talk to the person at HOPS who's helping to execute and do site recruitment, that's actually a Cerner person. That's someone that works on my team. All right, let's get to what you guys all came here for. So let's talk a little bit about clinical research in the EHR. When Cerner redesigned its patient-centric EHR back in the late 90s, one of our very early adopting clients was St. Jude Children's Research Hospital in Memphis. And at St. Jude, every single child is on a clinical trial. And so when our late co-founder, Neil Patterson, was on site in Memphis, they said, Neil, we need a way to track this patient information in the EHR. So we actually built a custom solution for them to put all that information in Cerner Millennium. And that's grown to a solution called Power Trials, which we actually initially implemented here about 3-4 years ago. So I don't think it's being used heavily across all studies. And so one thing to think about is the functionality that I'm about to show here, does that have a home for a protocol you're thinking about or a service line that may benefit from some of the things we're about to get into here? So this does exist. The back end of all this has been implemented in the EHR. So the first thing is clinician visibility to research. So the value proposition here is if a patient is on a study that you're running, if they have an unplanned encounter of some type and they show up in the emergency department, or maybe they have a connection with another provider, there's some safety level information that we believe should be fluid across the organization. And so what we actually do is we can place the clinical trial indicator in that patient's banner bar. So across anywhere in Cerner world, you actually see this patient's on a study, and that on-study indication information is pretty flexible. So we've had clients that change is it on-study versus on-protocol to make it kosher with the local IRB language. Do you want off-study or just for the whole thing to disappear? So that's definitely customizable. We've even had organizations that change the color of the banner bar even. So at Emory now, for example, they used to have the pink slips that were on the front of every paper chart. They actually churned the banner bar pink for patients that are on study. So there's some customization there that's possible. I don't know how much that we have the ability to implement on the fly here, but it's certainly something to think about on a protocol by protocol basis of should this protocol live inside Power Trial so you can actually track the patient status indication. What you'll see in the banner bar is, at the very top left is that on-study indicator, but also there's an M-page component that's associated to Power Trial, so you can actually see up front who is the principal investigator, when was the patient on study, who's the safety contact, so that information flows with the patient. It's not just living in a separate system. Some of you who sat through the really good Encore presentation, if you were here for that earlier, are also thinking, this information is already documented in Encore. So I'll hold that thought for a second, and we'll get a little bit into how that information could possibly be integrated here as well. The other thing is research power plans. So we do have the capability also of associating clinical trial calendar information into a power plan. So for certain studies, this may make sense to actually pull that clinical trial documentation into a power plan and assign it to a provider to execute that power plan. The main reason why this is done is actually to help out with the in-state revenue cycle. So what we don't want to do is let clinical trial charges that are dedicated to a sponsor land in some central CMS queue for billing. A number of organizations out there have gotten in quite a bit of trouble for this. I'm sure you could talk to the folks like at Rush University is one of the ones that's always mentioned. UAB had a challenge here as well, where they were actually inadvertently billing CMS for clinical trials charges in the EHR. So if a service is supposed to be rendered like a CBC, and that was supposed to be paid for by the sponsor, it should flow to the sponsor and not back to CMS. So this is actually a way to input that study account information right at the point of the orderable. And then the last kind of main functionality of what this Power Trials solution does inside the EHR is actually, we call it pre-screening. And pre-screening very specifically because while it's not replacing a screening visit, it is a way for you to actually match patients with available clinical trial information. So the way that's built out is we actually build rules inside the Cerner Millennium. It's called Discern is the framework where clinical decision support can be rolled out. We are limited to data that it's discrete and that it's captured as a static field. We have trouble with progress notes at this moment in time, but this is kind of an enhancement area for us. And ultimately can identify candidates who qualify for the study based on those rules. So you build out those rules at a protocol level and then reuse them over time inside the chart. And so let me skip here and show you what that ends up looking like is this. We're on the clinical trial tab, and you actually enable an end user to say, for my patient, and we see this most used in like the cancer center setting where an oncology trial may be the best course of care for that patient. What trials does my patient qualify for? And we also have the ability of doing the inverse of that, which is running a report for all the patients that may qualify for a specific trial and being able to do that on a repeatable basis. So that's Power Trials, and that's what that functionality does. The last thing, as far as actual workflow inside the chart and what you can do to help enhance the clinical trial process using what Cerner does. The first one is called researcher notifications, which once you have information about that this patient is on a clinical trial, is actually triggering notifications back to the study team at certain intervals. So we've seen a couple of client organizations use this pretty effectively. One, for example, is Florida Hospital in Orlando. So at Florida Hospital, they have like 18 different research institutes. They're a very large organization. They actually at one point they were the largest hospital in the country by number of ED visits every year. And what they were worried about was that because they're so disparate and they're all across Central Florida and not that dissimilar than the coverage area that you all have, they were worried that patients might interact with the health system in a way and not have the closed loop information come back to the study team to say this patient had an unplanned emergent encounter. And so what this does is it's actually an automated way of returning that information to the study team on an automated way to say, for example, all patients who have an emergent encounter, send me a secure message through the Cerner Message Center that this patient showed up in the ED at 2 o'clock in the morning, and that may represent an adverse event, that may represent some need for reporting or protocol deviation. What Florida Hospital also does is they also extend that through an SMS message out to the study team. So they actually get a text message that says, you have a patient that had an unplanned encounter, you should go follow up on that. Or essentially, it doesn't actually send any PII through the message, it just sends a message that there's a new something for them to follow up on in the message center. And then the second thing here with Power Trials is in terms of work for the research office or help to support the research office is what we call the auditor monitor workflow. What we found out, and I don't be curious to know what the current protocol is here, we actually found out that a lot of our clients were having a absurd amount of sponsor audit and monitoring visits from groups like Quintiles, GSK, Lilly, et cetera, who are coming on site and needing direct access to the chart And that was taking a whole bunch of time for some individual member of the clinical research team to go follow up, track that auditor when they were on site, make sure, maybe even print off a whole bunch of the chart to go send to them. So there's actually a way, and this can even be done even without a full deployment to power trials, to create a patient list and associate them to a specific auditor user. So for example, let's say that your auditor's name was John. When John came on site, you can assign a list specifically to John, and there's a very specific Millennium role that can be created that is read-only. They only have access to patients who are on that protocol. They can't edit, they can't print, they can't do anything to take that patient data off-site or off-premises. So again, something to think about, either whether it's at the IRB level, at the individual protocol level, or in individual lines of service that may be of use around power trials, or even just Cerner in general, inside what you've already implemented today that may be of interest. Yeah, question? Okay. Absolutely. And it doesn't actually require any further implementation. There's no new solution. It's actually just a Cerner role. So we have to work with the IT team to get that role created, but once that role is created, it can be used for individual users. So be happy to make sure that that gets shared. I know we've got kind of end here by 3:15 because you have some other content here. So let me skip forward just a hair to then talk about clinical research interoperability. So you all are heavily invested in Encore as your clinical trials management system, and that aligns you well with some other leading institutions. So we work with a lot of Encore clients, groups like Carolinas Healthcare in Charlotte, or now Atrium Health, Indiana University Health, Virginia Commonwealth University, all are Encore clients. They've done very well in the NCI designated cancer community. So what we want to avoid, though, as much as possible to go do all those things that we just talked about is what we call, or what the industry calls, swivel chair interoperability, as you all are probably familiar with, which is swiveling from to type something in this system over here and then feel like I have to fill it out in this other system. I think that's what this logo is supposed to be, was a swivel chair. So use your imagination. What we found was that there were a couple of standards out there that we're actually able to communicate with those external clinical trials management systems. There's one that's called Retrieve Protocol for Execution, or RPE, and there's one that's called Clinical Research Process Content. Both of them are really interesting ways that we can go out and communicate with Encore, or with about a half dozen other clinical trials management system vendors to automate the flow of information into the chart. So what RPE does is it actually connects the patient protocol information and the patient, or the protocol information and the patient information. So all that information I was showing at the beginning with the banner bar and the component that showed who the PI was, that actually can flow automatically from Encore into Cerner. So we developed that first with Carolinas Healthcare in Charlotte, and now have about 10 client organizations that are using that interface so that they don't have that duplication of data entry. And one thing I kind of forgot to mention at the outset is, even though Cerner is a giant organization, we have 8,000, I think, software developers at last count, we still require and know that for us to best serve you, we have to go work with other organizations. We have to go work with your other vendors to complete the story. Like, my team isn't going to go build a clinical trials management system to do all the things that you saw that Encore can do this morning. So what we're focused on instead is where do we, as your electronic medical record vendor, need to be very efficient and work closely with those other vendors to complete the information flow. And so this is an example of that where, and you'll hear a couple other examples as we go here, where it's not necessarily something that we're doing specifically, it's a way that we're working with another organization to make this happen. And this is an example where we actually use a industry standard to pull data into the system. And what ultimately happens then is Encore is the source of truth. It's the place where all protocol and patient information lives, and it gets updated in real time over to Cerner to say there is a patient that is now on study, the protocol has been updated, there's a new version of the protocol, all that information flows automatically without any other indication. The other thing that we can do, and you saw the power plan functionality before, which showed maybe here are the different labs that need to be ordered for this patient that's on study and it's going to flow into the Cerner system, is actually automating that as well. So that requires a syncing of the charge masters, which are the two, the list of ordables essentially in Cerner and the list of ordables over in Encore. We actually are starting this work for the very first time at Augusta University down in Georgia, and hope to be live with this by the end of this year, where we actually can automate that creation as well and use the study calendar, the billing grid, if you will, over in Encore, and automatically fill out a study calendar over in Cerner too to sync those two systems. So I said at the outset, not everything is something live and doable tomorrow, but this is an area where we're really focused on making life better. The last thing in terms of integrations, and this is mentioned also at the beginning, or an earlier conversation today was talking about REDCap and about the way that Cerner can actually fill out REDCap. We've worked a little bit with the team at Vanderbilt and are just working with other electronic data capture vendors in general, because I know for those of you who are very active in clinical trials, you've probably seen 2 dozen, 3 dozen EDC systems over the years. You've got Metadata Rave, you've got OpenClinica, Phase Forward, Oracle, OCRDC. Like that's a whole cottage industry in and of itself. What our focus has been, there's a informaticist that works on our organization who the quote he always says is, trying to develop a new standard without a use case for it is trying to push a cart up a hill with a rope. I think it may not make a whole lot of sense if you're not didn't grow up on a farm or something. But basically what that means is that we're not going to go out and create new standards to go support research use cases. That's really hard on the IT teams and organizations to constantly go implement X, then Y, then Z. Instead, what we're much more interested in is working on a single set of standards and then repurposing them for new use cases. So as you heard earlier today, there's already a lot of work in flight to use the FHIR, the Fast Healthcare Interoperability Resource Standard, those set of APIs, to push data out to external systems from Cerner. So it's structured in a standard way, push that in a standard way, and do that once rather than having to do it again and again and again and build umpteen different custom interfaces. So this is one we're actually very actively working on right now with a couple of different ADC vendors. So REDCap is in the middle, and I don't know how public this is, but they're building their dynamic data pull system is called DDP. They're building DDP on FHIR, so using the FHIR API to push data out to REDCap, so they've used our Sandbox to try and test some of that. We're also working with another EDC vendor called OpenClinica to basically do the same thing. And you'll see in the slides, and unfortunately we don't have time to go through every single step here, but the point ultimately is that you as an end user then wouldn't have to duplicate your data entry between different systems. You actually do a single push. You say, this patient is on a study. I'm going to push demographics, medication list, allergies, et cetera, out to the EDC system. It's sent in a standard way, and then that actually completes the case report form without needing to do extra data entry, or maybe just filling in the gaps of what wasn't already populated. So we're very excited about this and continuing to work here to use existing standards, because there are a whole bunch of other really cool things that are happening with FHIR and those interoperable resources. So kind of switching gears here from support for clinical trials into getting data out to go do other things with it. There's a quote, there's an interview a couple of months ago with the chief data officer of the Chinese search engine Baidu. And it was interesting, it hit me at the time that it was when the SpaceX launched their automated rocket, and it landed the reusable solid boosters in Orlando. It was super cool, or Cape Canaveral. And the quote was, data science is like launching a rocket. You need a lot of fuel and a really big engine. And I think one of the challenges that I see in our client organizations is they have a lot of fuel. That fuels the data. But sometimes they don't have a big enough engine to go do all the things with that data they'd want. And so the quote was like, if you have a lot of fuel but no engine, or a really small engine, you never really get off the launch pad. And if you have a giant engine but not enough fuel, you never really get to orbit. So what our focus here has been is making sure that our clients have a lot of fuel and a lot of data, and a big engine, which is the newer thing here, is basically how do we actually supply a whole lot of computing horsepower so that you all can go tackle the really challenging problems of the day that you're doing. So, and I know everyone here has got a pretty good idea of things you can do with healthcare data, but the super simplistic way of how I've structured this as I've talked about it was you certainly have the ability to do reporting. So moving data and representing it in some way to show it to someone else or take action on it. So basically sending data out of the system. That's something that's been done for years and years. Observational research and descriptive analytics. So actually using larger sets of data, not just to present on it visually or in a matter of a report, but do some higher order task of it. So to interpret, like some of the examples you saw earlier today, or things like, okay, what's our actual ED throughput in our cardiovascular service line, and what have we learned from how well we're doing? So asking some pretty challenging questions, and you need good infrastructure to go do that. What's really interesting, and certainly a buzzword I try and avoid using, but it's an important one, is machine learning. So actually being able to then take that data and not just do descriptive analytics using stats platforms like R, but actually using cloud and elastic computing power to go basically train a machine to learn things in an unstructured way that you wouldn't necessarily be able to do yourself in a lifetime. And then where we ultimately want to get with this, the academic component of this is really cool, and that's where so much insight is derived. But where we ultimately want to go is to be able to close the clinical intelligence loop. So take what we learn and then turn that into interventional predictive analytics, being able to say, hey, we've figured out a better way to go, a better set of patients to prescribe PCSK9 inhibitors, or a better flow through the hospital through a patient's life cycle inside our organization that results in a better outcome. How can we do clinical decision support, build programs around that, build a plan around that, and our role here, obviously is to contribute to that body of knowledge, but I think more importantly, and I say this probably a little bit biased as the research person from Cerner, is to equip you all to do that in a faster and better way than even we could. The challenges historically here, for those of you not knee-deep in the data science world, so this will be, obviously, Ryan, for those of you who are the informatics folks in the room, are, number one, is really complex data. We have as many data sources and data models, it feels like, as we have types of data. Like you've got, every EMR seems to look totally different. Your registration systems are totally different. Tumor registries are totally different. And so you got really complex data. The infrastructure is not the easiest part either. So for you to do really complex, large-scale learning on top of data sets, you need really complex, large-scale processing infrastructure to go do something with that. And also, and I say also elasticity is a little bit of a buzzword too, but I'm guessing that you all don't want to go build 10 supercomputers to go do all that. Like that's not cost efficient as an organization either. So you've got to have ways to only end up paying for what you're actually using. And then finally, there's a problem around adoption as I see it, that we as an industry, and I say this, I'm probably really stepping outside my lane here, but we as a healthcare IT industry, as a group of vendors, have a bad habit of going and creating another tool that could go solve this problem, when the reality is if we can solve the data problem, the infrastructure problem, the tools exist. Like Cerner doesn't need to go build a stats platform. Like there are really good ones out there. We have clients that are big SaaS shops. We have clients that use a lot of R. Like how can I bring the data to those systems that already work really well? And how do we make it accessible to the users that actually end up using it? So this is the world that I live in every day. It's the world that you all probably live in too, or some of you do. And now let's pivot from problem statement to what is Cerner actively doing about it. So the first thing is something that's already been adopted at Stony Brook, and that's the Healthy Intent platform. Healthy Intent was originally developed, it's about 5 years old or 6 years old now, and it's been implemented at Stony Brook for several years as well. The goal of Healthy Intent is to lift up healthcare data out of a single system. So we recognize that there is not some like nirvana world in the future where everyone's using a single EMR and all the data models just are in perfect harmony, and everyone's using Cerner, or everyone's using Epic, or everyone's using Athena Health, or the other 200 EMR vendors out there. A better world to shoot for is a way that we can actually action the data from all those disparate systems. And so the Healthy Intent platform is a cloud way in a data source agnostic way of onboarding, aggregating, and normalizing data. There are, I think as of the last time I looked, there are over 500 different data sources that we've learned how to interpret and pull into that platform. And it varies depending on each individual, one of our client organizations, how many different data sources they've pulled in. So the one you'll always hear Cerner talk about is Advocate Physician Partners in Chicago. They have about 55 different data sources that they pull into an enterprise data warehouse, and we've done that here for health. It's the ultimate data warehousing platform was called Healthy EDW. The goal, though, so while pulling that data in is great, the goal, though, is ultimately to make those data interpretable and usable to go do a variety of things. And some of those things may be contributing to the district project, maybe sending data out for syndromic surveillance, for public health lab reporting, basically pushing data in the variety of ways it needs to be pushed to go solve different use cases, or just being able to drive internal use cases of how can we make our organization better. Now that's Ryan, the Cerner associate. Ryan, the research associate, says, well, now we've got to figure out the enterprise data warehousing tools are really cool. What can we actually do now to make that research friendly, to actually push to the research organizations? And it was actually instrumental. I came here about 2 years ago with a couple members of my team, and we met with Dr. Saltz and his team, and they were like, well, Healthy EDW is cool, but there are some other things that we need to accomplish as an organization that beyond just being able to write SQL queries. Like, we need really robust, structured and unstructured access to data to go do all the things that we want to go do. And so that was where we came back to the lab, if you will, and said, what can we go do as an organization? What we ultimately ended up doing is leveraging cloud platforms to go make that happen. Because what we learned is that the data science users don't want, like I mentioned this earlier, don't want us to go build a new stats platform. They want to use the languages that data scientists already use. And so rather than Cerner going and building some new Cerner language, we actually use like Python as a standard way of interacting with that data. So we created a way to push data out to a Python interpretable framework. And then what our clients, as we did the roadshow and kind of learned what our clients wanted to do, we also just were continually reminded, Cerner, don't make me go buy 15 servers to go do this. Cerner, don't make me go assign a giant contract to go, you have a whole lot of infrastructure and framework that I don't necessarily have the time and energy or even dollars to go do. I don't want to go be a data center company. I want to go deliver health, and I want to advance the practice of healthcare. So this is the last of the partnerships that I'll talk about, is our partnership with Amazon Web Services. I'm guessing most of you in the room have heard of AWS. For those of you who haven't, basically Amazon, yes, the same Amazon that I just bought a new doorbell for my front door from, basically got so good at hosting and computing infrastructure that they sold that excess capacity out to the industry. And that AWS is now the most profitable part of Amazon. They are very, very effective and very strong at building that infrastructure, making it elastic, and then also layering tools and infrastructure, and now artificial intelligence and machine learning capabilities inside of that as well. So what we've done is we've launched a solution called Healthy Data Lab. And in my first bucket of, there are things that you can go do tomorrow as an end user, there are things that we're on the roadway to go doing, and there are things that are a little bit vision oriented. This is something we're hoping we're prepared to start rolling out this year, and ideally would like to get this in your hands as quickly as possible. Healthy Data Lab is AWS instance of all of our Healthy Intent data. So all of that kind of onboarding, aggregation, and normalization of data, we actually push that into what we call a FHIR-inspired data model. So we use the same underlying concepts and infrastructure that are in Fire are pretty similar to it. So for those of you who are already working on things like Fire-based APIs, know what a medication concept is. We use that same infrastructure, that same library to go instantiate that data out into AWS, and then we require about a dozen or so of Amazon's web services. So for those of you who are AWS literate, we use EC2, Elastic MapReduce, S3 obviously for storage, and ultimately produce a single environment for data science. What this ends up, I'll just cut to the chase here. What this ends up looking like is a closed loop though. So where we're headed with this isn't just to push data out of AWS or out into AWS, but actually make it so that a user can return the knowledge they've developed. So if we actually build a model and say, so our very first client that went live with this was the Children's Hospital of Orange County. And what they wanted to do at Chalk, the very first project out of the gate, was to study patient demise patterns through the hospital. So look at all the encounter data we had to be able to study, where are my patients most likely to perish inside my four walls, and how do I predict that, and how do I intervene against it? So if I know patients that move from this surgical unit over into this ICU are more likely to acquire some type of fatal hospital-acquired infection, like how do I avoid that? How do I then go ask more questions about that? And ultimately, once I learn what's causing that, how do I intervene and push some type of notification out to the clinician, or create a report, or create a dashboard that folks can go follow up on? So that's the ultimate goal. We are done with the first 4 circles here. It's that 5th circle which we'll be rolling out over the summer to be able to push a model back into the system. Really quickly, because I know we only have about 10 minutes left, maximum. I want to have some questions too if you guys have any. First of all is the access to that. So because we use AWS, you only have to pay for what you use. We have about 10 data scientists at Cerner who are full-time dedicated to working on this on our end. So we actually already do services like care management identification for our clients. So I want to identify all the using a variety of different social determinants of health, clinical data, identify patients who are at risk of falls, for example. Well, we already do that for some of our clients. So this is actually an internal tool we built first for our own use. Of those 10 users, though, what we've set up the environment to do is the environment itself only starts every morning at about 7:30 a.m., and it shuts the environment down every night at 6 p.m. So we as a company, even though we're a big company, we're still cost conscious, we don't want to pay for off hours computing power. So we actually shut all those servers off at night, and we're able to grow the number of computing clusters to a really large number during the day if we're doing a really complex problem. So what that ultimately means, though, is we're only paying for what we're using, but we have access to a theoretic infinite amount of computing power on a daily basis. We use that, like I mentioned, the Fire-inspired data model, and then we also have managed end-user security access. So what that means for you all is you can actually assign, or you can create a data mart inside this environment and assign that to a specific user. So there's also quite a bit of flexibility in terms of not everyone needs to see the entire data model. We can publish just a de-identified version of the full clinical data set to specific end users, which we see being pretty effective in an academic-like environment. The way that a user actually interacts with that data is through what's called a Jupyter notebook. Jupyter, it's Jupyter. It essentially looks like Microsoft OneNote, if you've not seen anything like it before. And you actually are able to make inline comments and then execute either Python or Spark ML pipeline code directly in there. So this is really a end user tool for the data science community. It's not a drag and drop interface at this time. It's a power tool, if you will. But in there, you can actually generate models, develop testing and learning sets, and use that full pipeline and also any other AWS tools you want. So the environment we create ultimately is the property of the client who we're creating that environment for. So one of our clients has asked, can I pull in AWS Poly, which is their a natural language processing tool? Can I use Poly to push another data set in that maybe has a whole bunch of free text? And the answer is yes. Like, it's your environment. You're ultimately paying for that, for what the use that you do have. So it does give quite a bit of flexibility. Obviously, there's you've got a really large data set to validate against the entire set of healthy intent data. So when we do our own care management identification or do algorithm simulation on our end, because we have access to just for our own internal use for solution improvement to up to over 100 million records, we can develop those algorithms pretty quickly and have a really large data set that we have a lot of confidence in. But ultimately, the goal, though, is not just to build the model and publish it, though that is a goal, but then implement it down in the workflow. So here is the world's most simplistic example of what that environment looks like. And ultimately, we just pull in both the identified and the de-identified healthy intent data that we talked about earlier into that S3 environment and then expose through Jupyter and Spark ML. So that was a lot of information. I know we've got about 10 minutes left. So what questions can I answer? What thoughts do you all have, or how can I help?